Hello, good morning. CTS266, Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the Cisco CCNP Switch course, and this morning's video tutorial is going to be on Cisco Learning Labs activity number 4, where we're going to be taking a look at DHCP, or the Dynamic Host Configuration Protocol. So let's go ahead and dive in here. You can see we've got a pretty basic setup where we've got a layer 2 switch that connects into a multi-layer switch, and then 3 PCs, and we're going to be configuring the multi-layer switch, distribution switch 1, to serve as our DHCP server. So let's go ahead and dive right in here. And actually, let me come over here, and we need to correct something real quick. And let's drop that out of the way. So let's go ahead and switch over to Web Telnet. And then we're going to make the text, excuse me, as large as we can. All right, so now let's go ahead and pull up that distribution layer switch. We're going to go from user exec into privilege exec in the global config. Now, this is often a common question that comes up. Well, how do I exclude addresses from being used? Well, you could simply put IP DHCP, excluded address, and if I do a question mark, you can see that we can put a low address and a high address. So we could put a range in here. And one of the more confusing use cases is, well, I don't want a range. Let's say we wanted to pick 10.0.10.1, which is probably the default gateway address. So I would say IP DHCP excluded address 10.0.10.1. Well, what if I wanted to exclude all of the odd numbered IP addresses up to .9? So what you can't do, and you can see here, if I were to put a high address, if I were to say 10.0.10.9, that statement is actually going to exclude .1, .2, .3, .4, .5, .6, .7, .8, and .9 inclusive. So if we wanted to get just the odd addresses, what I'd end up doing is I would literally have to put in a statement for each of the odd addresses. Now, typically, you're not going to be blocking all of the odd addresses, but this is to show you that if you use the range, it's going to get everything inside that range inclusive. And what I mean by inclusive is that it's going to get the first address that you would specify, which would be the .1, and then if I put 10.0.10.9, it's going to get everything between 1 and 9, including .1 and .9. This is only going to get .3, .5, .7, .9, and again, we've already put the .1 in here. So this would be the way that you would approach sort of picking off individual addresses that don't run in a numerically consecutive order. All right, so let's clear the screen there. So that's just a quick note on the IP DHCP excluded address. And so these are addresses that are not going to be offered by the DHCP server, which in this case, again, we're setting the DHCP server up to be the distribution switch 1. So now let's go ahead and create our DHCP pool. So I could say IP DHCP pool, and then we want to give it a pool name. So we're dealing with VLAN 10. So we'll just say VLAN 10-pool. So now you can see I've dropped into a DHCP configuration mode here. So let's throw a question mark in, and you can see here are all the options that we have available to us. We're most concerned with some of the basic options. Again, this is easing us into the configuration of a DHCP server, and the first thing that we want to specify is the network. So in other words, the network number and mask. So for VLAN 10, what is our subnet? Well, it's going to be 10.0.10.0, and we have a class, we have a class C subnet mask applied to a class A address, that 10.0. So we're going to do a /24. So in other words, we're going to have 254 usable or host assignable IPs that are going to fall into this network range, or this subnet range. So that tells the DHCP server what address range are we going to be offering addresses for? So if I were to say do show run section DHCP, you can see that we have the excluded addresses. So again, those addresses right there, 13579, those are not going to be offered up by the DHCP server. Here's the pool name, IP DHCP pool VLAN 10 pool, and that's the network for VLAN 10 from which we are going to offer addresses up. It's just that these will not be offered. And typically, the reason that you exclude addresses is because you're using them for something else. So I believe the lab showed this as the only address that we were going to exclude, and that's probably because it is going to be our default router address. So again, if you had infrastructure addresses that you did not want to have offered up, you would simply do your exclude statement. All right, the next statement is going to be the default router, right? So you can see right here we have default router, and we definitely want to let the, again, because remember, we're pushing this information down. The information is going to get pushed down from our DHCP server here, who is DSW1. This information is getting pushed down to the various DHCP clients, who are going to be PC 1, 2, and 3, and they're going to need to know what is their default gateway address. And I can almost guarantee that it's going to be that guy right there, 10.0.10.1. And so when these PCs receive their DHCP information, we can share with them other information, and we definitely want to make sure that the information that's getting shared, or one of those pieces of information being shared, is the default gateway. That way, if PC 1, 2, and 3 are trying to get to something that is not in VLAN 10, and they have to go through a default gateway, they know what that default gateway address is. So let's jump back here onto DSW1, and let's put in our default router setting. So it's going to be 10.0.10.1. Now, there's also some additional information that we could put in here. I could put in a DNS server. So if I were to say DNS server, I could say, 192.168.1.23. And again, I'm just throwing an address in there. This isn't actually part of the lab. So I could say DNS server 192.168.1.23 and hit enter. So now we have a DNS server, and that information can be passed along to the hosts that are receiving this DHCP request. I could also specify the lease time, right? So you can see we can specify it in a number of days. So let's put in here 3 days. So lease 3. So now if I say do show run, pipe it to section DHCP. So there is my DHCP section right now. We've got some excluded addresses. We've got the pool name defined. We've got our default router. We have our DNS server configured, and we also have the DHCP lease set up. So let's go ahead and type in. We'll say write mem to save our config. So if I were to say show IP DHCP pool, right, I can see it in a little different format here than doing that show run section. And so here is the pool information that we have right now. And as you can see, we have the pool name. We've got this utilization high-low, high being 100%, low being 0%, subnet size, first and next, total addresses, so 254 total addresses. But here is our key. We excluded .1, .3, .5, .7, and .9. So 1, 2, 3, 4, 5. There are the 5 addresses which we've excluded. Pending event is none. We have one subnet is currently in the pool, and we know that subnet is from 10.0.10.1. That's our index. And then we've got the range 10.0.10.1 to 254. And again, we see excluded 5. So in reality, we have 249 addresses that we could give out, starting with .2, and then .4, .6, .8, .10, .11. Again, remember, the excluded addresses don't include the even numbers that fall between these odd numbers here. So we should see .2, .4, and .6, that those are going to be the first addresses to be assigned. All right. So now what we're going to do on DSW1 is we're actually going to kick off a debug here. So we're going to say debug IP DHCP server packet so we could see the packets that are going back and forth. Now let's go ahead and turn DHCP on, and we're going to do it on PC1 initially here. So we're going to go from user exec to privilege exec and into global config interface Ethernet 00, where we're simply going to say, and let's actually do a do show run interface Ethernet 00. Let's see what we have here. So interestingly enough, that IP address DHCP statement is already there, and we're going to go ahead and don't need to add it, so we'll just simply say no shut. Now what we should see when we come over here to DSW1, and actually let me make sure that that stayed on there. Do show run interface Ethernet 00. Yeah, so we've got, whoops, and it did not like that. So let's try that again. That actually just crashed. So let's try that again. Let's say shut, and let's see if this is going to cooperate with us here. And then, oops, sorry, no shut. And let's see with the debug, and there we go. All right, so we're definitely seeing the conversation, right? And the easy way to remember it is the initials DORA. So discover, offer, request, acknowledgement. So you can see here that we have a DHCP release message. Actually, this is kind of out of order because of the crash. The offer, or the discover the offer. So here we go down here. So we can see, let me get my pen turned on here. You can see the DORA taking place, right? Or DORA, discover. So here is my DHCP discover. So it says receive from client, and it gives me the layer 2 hardware address, right? And this is actually going to end up being this long string of numbers here is the client identifier on VLAN 10. So here's my discover. So there's our D, and then we have sending DHCP offer. So there's the O. So the discover is being sent from the client, and it goes out as a broadcast. Then we have an offer to the client. So this is to PC1. So here we're from PC1. The offer is to PC1. And what is the offer that's being given out? Well, we said we start at .2, but that was what we first had there, right? So and then he released that address. So now he's trying to scoop up 4. He's taking the next address. Because again, the lease, we had it out to 3 days, but it crashed, and so we've got some unpredictable behavior here right now. So here you can see the address that's being offered up. No option 125. What else is in here? And then they have the R. So here's the DHCP request from the client. So here's the R. And then we have a acknowledgement. Here is the DHCP ACK. And so that is where we come up with that mnemonic DORA. Discover, offer, request, acknowledgement, right? And so now PC1 ends up acknowledging that yes, I am going to use, or that yes, PC1 is being told, yep, you're going to be able to use, that the DHCP server is acknowledging that yes, you're going to be using 10.0.10.4. So let's jump onto PC1 right now, and let's take a quick look and see what PC1 shows. So if I said do show IP interface brief, you would see that the IP address that we have is that 10.0.10.4. And again, that debug gives us a great deal of visibility into the discover, offer, request, ACK. Now, one of the things to remember with that whole DORA process is that the discover goes out as a broadcast, right? However, the offer is unicast. The request goes back as a broadcast, or we'll just say bcast, goes back as a broadcast, and then the ACK is a unicast. And so again, I had a student one time tell me the easy way to remember is that the vowels, right? If it's a vowel, A, E, I, O, U, and in this case O and A, that it's going to be unicast, right? That was their way of sort of trying to remember things. And then if it wasn't a vowel, it was going to be broadcast. Okay, so there's also some additional messages that we may see in the debug output, and we saw the one already, the DHCP release. And that's simply the client telling the server that it is giving up its lease. So instead of that 3-day lease, he's giving it up immediately, and then the DHCP server could give that out again. You've got a DHCP inform, where that's a message where a client already has an IP, like this client here, but he's going to request maybe some additional parameters. It could be the DNS server. It could be just about any other parameter that DHCP server could be offering. And that's what the DHCP inform is. And then we've got the DHCP decline, and that's a message sent from the client to the server saying that the address is already in use. And then finally, the DHCP NAK, or NAK. And that's where the server sends a refusal to the client for its request for configuration. All right, so now let's go ahead and jump onto PC2 and PC3, and let's get them configured as well here with DHCP. So let's go back to our diagram. Let's choose PC2 and PC3. We'll start with PC2 here. So we'll go from user exec to privilege exec into global config, interface Ethernet 00. Let's say do show run interface Ethernet 00. Yeah, and it already has that IP address DHCP statement in there, but if I say do show IP interface brief, you'll notice there's nothing to sign yet because it's shut down. So we'll say no shut. We've got our debug still running here, and here we go. So now we're going to see the conversation that comes in from PC2. Again, doing the debug, we're talking about DORA. So there's the discover, offer, request, acknowledgement. And you can see that it picked the next address up. So we had .2 initially, and then excuse me, things crashed. Then we had .4, now we have .6. So what address do you think PC, let's clear the screen here. What address do you think PC3 is going to pick up? Well, let's find out. So we'll go to privilege exec, into global config, interface Ethernet 00, and we're just going to say no shut. I'm assuming that, put some space in here, I'm assuming that it already had that IP DHCP, and it did. And if you guessed .8, you're absolutely right. So it just kind of starts to pick off the addresses in numerical order, excluding those addresses, the odd numbered addresses that we told it we did not want it to pick up. Well, now that we've got 3 DHCP clients here, let's go ahead and say show IP DHCP binding. And so here's a list of the hosts that are using DHCP information off of the DHCP server. You can see that we also have that random string of characters, which actually turns out to be the DHCP client ID. And you can see here that it works the MAC address in there as well. So that is the client ID for .4. There's the client ID for .6 and the client ID for .8. It shows us the lease expiration, when that's going to happen. So 3 days from now would be March 6th at 6:32 a.m. And it was automatically, and this is as opposed to statically, it was automatically configured. And so again, that show IP DHCP binding is going to give us some great information that we could then use. Let's say we wanted to do a static assignment, because in some cases you want to lock things in so that a specific client, gets the same address every time. So we're going to do it with .6. We'll do it with the guy in the middle here. And so you can see that there is the client ID, and we're definitely going to need that client ID number in order to make this happen. So if I was to narrow down my display output here, and if I were to say show IP DHCP binding for 10.0.10. and we're going to use 6, you can see that we get the binding only for 10.0.10.6. So now what we want to do is we're going to clear the DHCP binding, and let's go ahead and say clear IP DHCP binding for 10.0.10.6. So now if I were to say show IP DHCP binding, you can see it's not in the database. If I were to just simply say show IP DHCP binding without the address, you can clearly see it's not in the database, but we need that random long number. And this is the not so fun part of trying to get this in here. And I'm trying to think. I don't believe there's an easier way right now than simply typing this in. So let's get into global config, IP DHCP, DHCP pool, and we called ourselves, was it VLAN or VLAN 10-pool. And let's give an address. So we're going to say host 10.0.10.254. Let's grab that very last IP address here, and this is a /24, right? Whoops. This command may not be used with network origin VRF relay pools, and that's okay. And so let's go ahead and say do show run section DHCP. And it's blocking. Oh, I'm sorry. I dumped into the name of the pool. We need a new pool. So we're going to say IP DHCP pool. Sorry about that. I was thinking we needed to go in the same pool. So for the static binding, we're just going to go ahead and say PC2 dash. Well, we didn't even need the pool. So we'll say PC2. And the reason that we got that message is because we have the network statement here. And because that network statement is there, we can't use the host statement. All right, so we're going to say host 10.0.10.254, and we're going to give a /24 address there. Now the hard part. So client identifier, and our client identifier is this random string of characters here. And let me see if I can do Control-C and then Control-V. And that is not going to work. And so are they actually going to force us here to type all of that in? And it looks like we're going to have to type all of this in. So give me a second here. I'm just going to pause and let me get this typed in so you have to sit here and watch me type this in. And then we'll be right back. All right, so we've got the client identifier typed in here. So now let's go ahead and say do show run and section DHCP to see what our DHCP section looks like. And so there's the client identifier. Took us a while to get that typed in. So now that we've got the binding manually configured, only that PC, when we're talking about PC2 here, is going to be able to get that address, and it's going to actually lock that address in. So let's go back to PC2 now. And if we were to say do show IP interface brief to see what PC, what address it had, let's go ahead and force that address off of it again. So we're going to go ahead and say clear IP DHCP binding, and we're going to, let's just clear them all right now. So we'll clear them all. So if I were to say show IP DHCP binding, you can see that that is the one that we have, and that is it. So we cleared them all out, and it's the 10.0.10.254. If I come back over here to PC2, and you can see we still have that 10.10 or the 10.0. Let's go ahead and say shut. So we're going to shut that interface down, the Ethernet 00, because it still has a entry for that IP. And then we're going to say no shut. And now is when we would expect to see it pick up the address that we had locked in, and there we go. So we cleared the binding on the server, but the host still had an entry for that 10.0.10.6. The way to get rid of that, just simply shut the port down, no shut the port down, and you can see here DHCP address assign, and we end up with our 10.0.10.254. Let's take another look over here, and you can see that what ended up happening was that we still had the DHCP configuration, but it's because the request came in from the client ID that we had manually specified. Again, show IP DHCP binding. And there it is right now, the lease expiration. It's an infinite lease, and it is a manual type entry. Now you're probably asking yourselves, why would I not just simply exclude this address and statically configure it on the PC? And that would certainly be another approach. If you don't enjoy typing in those client identifiers, you could certainly do that. Just do IP DHCP excluded, drop that address in there, 10.0.10.254, excuse me, and then turn around and manually and statically configure the IP address on the PC that you're trying to do this process for. So again, this is DHCP, a good introduction. We're going to get into DHCP a little bit more in the Netacad labs. And that is it for Discovery Activity number 4 on DHCP. All right, enjoy the rest of your weekend, and I will see you all tomorrow night.